Hello, in this lecture we'll find out the area of a square. In the drawing we have the right triangle ABC. Inside this right triangle ABC we have this square DEFG, and our mission is to find out the area of this square DEFG. In addition, we know that side AB of this triangle ABC equals to 5 units in itself, side BC equals to 12 units in itself, and this is angle ABC, this is a right angle. Again, our mission is to find out the area of this square DEFG. So first of all, we find out the length of the hypotenuse AC of the right triangle ABC. So in the right triangle ABC, here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. It again, according to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. In conclusion, found out that AC square equals to 25 plus 144. 25 plus 144 is 169. Here we take a root out of this equation, and finally we get that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC, this right triangle ABC, is 13. So I write it down here. AC is equals to 13 units in its length. We have the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. Again, the sum of the angles on one side of a straight line is equals to 180 degrees. So we know that line segment AC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of AC at point E here? We have this angle that is a right angle plus this missing angle. In total they must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in the lower side of the straight line AC at point E to 180 degrees, the missing angle here must be equal to 90 degrees in its sides. Likewise, if we focus on the lower side of the straight line AC at point D here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of AC at point D? We have this angle that is a right angle plus the missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle here must be equal to 90 degrees in its size. In the next step, we'll define the length of line segment BG as x. So what is the length of line segment GC? From the drawing it is very easy to see that GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC that is x. So in total, GC equals to 12 minus x. GC equals to 12 minus x units in its length. In the next step, we define the length of one side of this square DEFG as L. So DE equals to L units in its length according to our definition. Therefore, all the three other sides of this square DEFG must be also equal to L because of the fact that all the sides of any square are equal to each other. So DF is L, EG is L, and FG is also L. In the next step, we define this angle, the natural angle ACB, as alpha. And here we'll focus on the right big triangle, triangle ABC. On the right big triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Therefore, the missing angle here must be equal to 90 degrees minus alpha. So, we will define 90 degrees minus alpha as beta, and therefore the missing angle here must be equal to beta. So we know that 90 degrees minus alpha equals to beta. If we add to this equation alpha and then subtract beta, we get that 90 degrees minus beta equals to alpha. In the next step, we'll focus on this right triangle, triangle AFD. On the right triangle AFD, this angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle equals to alpha. Likewise, we focus on the right triangle GEC. On the right triangle GEC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Here, 90 degrees minus alpha equals to beta. And therefore, the missing angle here equals to beta. In the next step, we will focus on what is line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So BC is the straight line. We'll focus on the upper side of the straight line BC at point G here. So which angles we have at the upper side of BC at point G? We have this angle that is beta, this angle that is 90 degrees, plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles that is the sum of the angles on the upper side of the straight line BC. So the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Here, 90 degrees minus beta equals to alpha. And therefore, the missing angle must be equal to alpha. So in the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta here. And therefore, the missing angle here equals to beta. So, in our drawing, in total, we have 4 right triangles, 1, 2, 3, and the big right triangle, triangle ABC. On those, all 4 right triangles, all the angles are equal to each other correspondingly. Why? Because each right triangle has the three angles that are alpha, beta, and 90 degrees. And therefore all the three angles in each triangle are equal to the angles of the other triangle. Therefore, those four right angles are similar to each other according to angle similarity rule. So, for example, the big right triangle ABC is similar to this small right triangle FBG. So I write it down. The big right triangle ABC is similar. This is the sign of similar to the right small triangle FBG. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that BG over FG in the right small triangle FBG is equals to BC over AC in the right big triangle ABC. Repeat again. From the fact that triangle ABC is similar to triangle FBG, we derive that BG over FG equals to BC over AC. So BG is X over FG is L, and it is equals to BC is 12 over AC is 13. In conclusion, found out actually that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and we get that according to equation 1, X equals to 12 L over 13. Likewise, we also note that the right big triangle ABC is similar to the right triangle EGC. They are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side GC over side EG in the right triangle EGC is equals to side AC over side AB in the right big triangle ABC. Repeat again, we derive that GC over EG in the right triangle EGC equals to AC over AB in the right big triangle ABC. GC is 12 minus X over EG. EG is L, and it is equals to AC is 13 over AB is 5. In conclusion, found out that according to equation 2, 12 minus X over L equals to 13 over 5. Here we will multiply this equation 2, and we get that according to equation 2, 5 times 12 minus X equals to 13L. Here we'll open the brackets on this side of this equation 2, and we get that according to equation 2, 5 times 12 is 60, and 5 times minus x is minus 5x. And it is equals to 13L. Here we'll add 5x to this equation, equation 2, and we get that according to this equation, equation 2, 60 equals to 13L plus 5x. Here we subtract 13L from this equation, equation 2, and we get that according to equation 2, 60 minus 13L equals to 5x. Let's see it again. We actually found out that according to equation 2, $60 minus 13L equals to 5x. In the next step, we'll substitute x in this equation, equation 2, by the value of x that we found in this equation, equation 1. According to this equation, equation 1, x equals to 12L over 13. Therefore, we substitute x in this equation, equation 2, by 12L over 13. We'll do it now, and we get that according to equation 2, 60 minus 13L equals to 5x, and x according to equation 1 is 12L over 13. In conclusion, found out that according to equation 2, 60 minus 13L equals to 5 times 12L is 60L, so in total this expression equals to 60L over 13. Here we multiply this equation, equation 2 by 13, and finally we get that 60 times 13 is 780, minus 13L equals to 60L. Here we get to this equation, equation 2, 13L, and we get that according to this equation, equation 2, 780 equals to, actually, we have here, we multiplied this equation, equation 2 by 13, and found out actually 13 times 60 is 780, and 13 times 13L is 169L. Again, 13 times 13L is 169L. In conclusion, found out that 780 minus 169L equals to 60L. Here we get to this equation, equation 2, 169L, and we get that according to this equation, equation 2, 780 equals to 169L plus 60L equals to 229L. In conclusion, we found out that according to equation 2, 780 equals to 229L. Here we will divide this equation, equation 2, by 229, and finally we get that L equals to 780 over 229, and 780 over 229 is equals to 3.40611. L equals to 3.40611 units. So the length of one side of this square DEF GL equals to 3.40611. So the area of this square DEFG is equals to one side squared. One side of this square is L, therefore it is L squared. The area of square DEFG equals to L squared. L is 3.40611, and therefore L squared is 3.40611 squared. That is equals to 11.6016 square units. In conclusion, further, the area of square DEFG is equals to 11.6016 square units. And that is the answer to the question. Repeat again. The area of this square DEFG is equals to 11.6016 square units. Okay, so in the next step I will summarize the lecture. In this lecture we found out the area of this square DEFG. So in the drawing we have the right triangle ABC. Inside this right triangle ABC we have square DEFG, and our mission is to find out the area of this square DEFG. In addition, we know that the length of side AB of triangle ABC, of the right triangle ABC, is equals to 5. The length of side BC is 12. Again, our mission is to find out the area of this square DEFG. So first of all, we found out the length of the hypotenuse AC. According to the Pythagoras theorem, of course, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again, in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. So in conclusion, we found out that AC square equals to 25 plus 144. 25 plus 144 is 169. So in conclusion, we found out that AC square equals to 169. Here we took out of this equation and finally found out that AC equals to the square root of 169, that is 13. If the length of this, the hypotenuse AC is 13 units. In the next step, I presented to you the rule that we know, and that the sum of the angles in one side of a straight line is equal to 180 degrees. Line segment AC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the lower side of the straight line AC at point D here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle must be equal to 90 degrees in its size. Likewise, if you focus on the lower side of the straight line AC at point E here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is 90 degrees plus the missing angle. In total they must be equal to 180 degrees. Therefore the missing angle must be also equal to 90 degrees. In the next step, we define the length of this line segment VGSX, and GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus BG, that is x. So in total, EC equals to 12 minus x. Then we find one side of this square DEFG is L. Therefore, all the other three sides must be also equal to L, because of the fact that all the sides in any square are equal to each other. Okay? So, in the next step, we defined the size of this angle, that is actually angle ACB, as alpha, and we focus on the right big triangle, triangle ABC. In the right big triangle, triangle ABC, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees, that is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus alpha. We defined 90 degrees minus alpha as beta, and therefore the missing angle here must be equal to beta. If 90 degrees minus alpha equals to beta, here we will add alpha and then subtract beta for this equation, and we get that 90 degrees minus beta equals to alpha. Okay? Then, so here this angle equals to beta. Then we focus on the right small triangle AFD, in the right small triangle AFD, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle must be equal to alpha. Then we focus on this right triangle, triangle EGC. In the right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. Then we focused on, actually line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of this straight line BC at point G, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of BC at point G here? We have this angle that is beta, this angle that is 90 degrees, plus the missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC. So the missing angle must be equal to 90 degrees minus beta, but 90 degrees minus beta is alpha, and therefore the missing angle must be equal to alpha. So in the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta, and therefore the missing angle must be equal to beta. So we actually found out that all the triangles in our drawing, in total we have 4 right triangles, 1, 2, 3, and the big right triangle ABC. In total we have 4 right triangles, 4 right triangles. All the angles of all those 4 right triangles are corresponding equal to each other. Each right triangle have the 3 angles that are alpha, beta, and 90 degrees. And therefore, all those 4 right triangles are similar to each other according to angle similarity rule. For example, the big right triangle ABC is similar to this small right triangle, triangle FBG, according to angle similarity rule. They have exactly the same angles, beta, alpha, and 90 degrees. Therefore, they are similar to each other. And because of the fact that the right big triangle ABC is similar to this small right triangle FBG, the following relationship exists between their sides. Side BG over side FG in the right triangle FBG equals to side BC over side AC in the right big triangle, triangle ABC. Repeat again. BG over FG in the right triangle FG must be equal to BC over AC. BG is X, FG is L, BC is 12, and AC is 13. In conclusion, we found out that according to equation 1, x over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally found out that x equals to 12L over 13. This is according to equation 1. Likewise, the right big triangle ABC is similar to this right triangle, triangle EGC according to angle similarity rule, and therefore the following relationship exists between their sides. GC over EG in the right triangle EGC equals to AC over AB in the right triangle, triangle ABC. I repeat again, GC over EG equals to AC over AB. So GC is 12 times X, EG is L, AC is 13, and AB is 5. In conclusion, we found out that according to equation 2, 12 times X over L equals to 13 over 5. Here we cross multiply this equation, equation 2, and finally found out that 5 times 12 times X equals to 13L. Here we open the brackets on this side of this equation, equation 2, and found out that 5 times 12 is 60. And 5 times minus x is minus 5x, that is equals to 13L. Here we added 5x to this equation, equation 2, and finally found out that 60 equals to 13L plus 5x. Here we subtracted 13L from this equation, equation 2, and finally found out that according to equation 2, 60 minus 13L equals to 5x. So here we substitute x in this equation, equation 2, by the value of x that we already found out in equation 1. According to equation 1, x equals to 12L over 13. Therefore, we can substitute x in this equation, equation 2, by 12L over 13 from equation 1. We did it. So we have here 60 minus 13L equals to 5x. And x is 12L over 13. In conclusion, we found out that 60 minus 13L equals to 5 times 12L over 13. So 60 minus 13L equals to 5 times 12L is 60L. So in total, this expression equals to 60L over 13. Here we multiply this equation, equation 2, by 13. And finally found out that 60 times 13 is 780, and we have here 13 times 13L, 13 times minus 13L is minus 169L, that is equal to 60L. So in conclusion, found out that according to equation 2, 780 minus 169L equals to 60L. Here we added 169L to this equation, equation 2, and finally found out that according to equation 2, 780 equals to 60L plus 169L is equals to 229L. So 780 equals to 229L. Here we divided this equation, equation 2, by 229, and finally found out that L equals to 780 over 229. 780 over 229 is 3.40611. So in conclusion, found out that L equals to 3.40611. So the length of one side of this square, L, is 3.40611 units. Therefore, the area of this square equals to L squared. The area of square DFG equals to L squared, that is one side square, that is the area of any square. L is 3.40611, therefore L squared is 3.40611 squared, and 3.40611 squared is equals to 11.6016 square units. In conclusion, found out that the area of this square DEFG is equals to 11.6016 square units. Okay, thank you very much.